Hi everyone, in this video we're going to talk about logic gates and how to use them in analog circuits as opposed to using them in digital circuits, because that's what basically they're designed for. The digital gates, basically they only have two state, on and off, or 1 or 0. So how do we use them in our analog circuit, and why should we use them in analog circuits? Well, basically they perform operations. That's what they are, and they're good in both circuits, analog and digital circuits. I'm going to talk about AND gate for the timing for today, and I can do other videos to talk about other gates. If anyone's interested, just leave it in the comments, and then I can do videos on other gates, other logic gates as well. But today we're going to talk about the AND gates, and everyone should be familiar with the AND gate. You have two inputs, A and B, and you have an output which I've marked X. And you should know the truth table for your AND gate. So you have your A and B, and you have your output. And the only way the AND gate gives us an output is when both inputs are high. So basically you're ANDing A and B, and you get your X out. So this is the truth table, very simple. You should familiarize with this because this is basically what shows you what you can do with this gate basically. And I'm talking about the CMOS at this time because I've designed a little circuit to show you what I mean by using in an analog circuit. But you can use TTL, but TTL only goes up to 5 volt, maximum 6 volt, and the 6 volt is its absolute rating, and you never want to push any ICs to its absolute rating, which is rated showed in the data sheet, because that's absolute is you're in the gray zone, so anything can happen. It's not guaranteed that it's going to work properly. It's absolute. But for TTL, the logic 1 is 2 volt and above, and for CMOS, logic 1 is 3 volt and above. I'm using CMOS because I'm in the analog circuit. So with analog circuits, your voltages can be 10, 12, 15, 20, or whatever it is. Obviously, you can't use the CMOS with 20 volt. I think they go to maximum, absolute maximum is 15 or 18 volt. But today I'm using for 10 volt in my circuit. And CMOS, you need to be careful when you handle CMOS ICs because they're MOSFET based, so they can get zapped if you got the static in your body. But TTL, the transistor based, so they're safe to touch and handle without, without worrying about static and things like that. But today we're talking about CMOS because I'm using 10 volts. So this is a little circuit I've made. That's why I'm talking about using it in analog circuit. As you have A and B input, by the way, you can get AND gates with multiple inputs. There are AND gates with 2 inputs, 3, 4, 8 inputs AND gates. And what you can do, you can cascade this. So you can buy 5 or 6 quad package and just put them together and have multiple and basically input AND gates. What you can do is, if I quickly grab, and I can just quickly draw over here, so we have one AND gate here, and then you can have another AND gate. Oop, it went funny. And you can tie the input, and here now you have 3 input AND gates. And what I can do, I can add another AND gate here, put it to one of these, and now I have 4 input AND gates. And you can, you can just cascade them and have as many input as you want. Say you have 10, 15, 20, or whatever your circuit is. Say you have 5 or 6 different inputs that need to be activated for your output to come on. You can just cascade and have 5 or 6 different input and feed each of your input of your sensors or whatever you have. And once they're all on, your output becomes on. Okay, so they're easily scalable. Okay, so you should never worry about that part of it. So what do I have over here? I have 2 light sensors, just a simple circuit I have. I have one which is on the left, I have one which is on the right, and the output of those 2 are feeding into one AND gate, and it's going to give me an LED indication that the both outputs are on. And then what I have a local oscillator, which is an op-amp based oscillator here, feeding to another set of AND gate, and then the output of the first AND gate is feeding into one of the input and the oscillator on the other input, and the output is going to go into my buzzer. Basically what I'm doing, I'm gating the oscillator, because remember the oscillator is a square wave, so it keeps going 1 0 1 0 1 0 1 0 in whatever time scale that I have. And once I activate one of the input, and because the oscillators keep going on and off, on and off, on and off, I'm going to get that passed into the output, which this is very good function of a digital circuit. You can use many oscillators to gate them into your circuit. So that's the circuit we talk about, very simple design, and I have it over here if it's visible in the shot. So I have 10 volts going into my system. I have one bypass capacitor there. This is my buzzer. This is the left sensor. This is the right sensor over here, if I uncover it. And I'm scoping the output of the final output here where the buzzer is. And this is my oscillator. So if I bring my hand here, you can see the left sensor gets activated. If I come here on the right, you can see the right gets activated. So individually, I get no output indication. Okay, so for instance, this is a garage, and we got a car going. So you press your door, the door opens up. So that's one input. So the door is open. So we got one input, and the car goes into certain length, and then we have another sensor that comes on. And as you can see now, we have our output. We got the buzzer coming on, and we got our light coming on. Okay, I know you can do this in digital domain, and like, you know, have microcontrollers and all kind of other fancy stuff, but I just wanted to show you that logic gates can be used in analog circuits to perform the same exact function they perform in digital, obviously, but you can use them, because to have something like that done in analog with transistors and stuff like that, you can do it, but it's going to be messy. This is a simple IC. You got 4 of the AND gates inside, and you can use it many different versions in your circuit and stuff like that. I'm using a dual 3-input AND gate because that's what I had available. I didn't have the quad package one, but it's very simple. All I had to do was I had an AND here with 3 input. I just tied 2 of the inputs together, and now I have 2 input AND gates. Very simple, because and you have to have all the inputs high for the output to come high, so you can combine them together and get whatever you want. But as you can see, both inputs on, and I get my AND function happening. Individual, nothing happens. Both, it comes on. Let's look at a scope, and what does the scope show us? So let's look at the scope. There we go. You can see I am gating the oscillator. There we are. I can turn the light off completely, and the thing comes on because they're both activated. There we are. And you can see how simple that is to use it in analog circuits. They're not always designed just to be used in digital circuit. You can use them in analog circuits as well. And you should, because they make life very simple for you. This is just an AND at the moment, but we have many different logic that we can use. We can do many different functions, different operations in our analog domain. And it helps a lot, because to go completely analog and just use transistors and other things to perform that, you can do it, but why would you want to do that when you can use an IC which has 4 of these, and you can use the other state, the other part in different section of your in your project. Always, you need to always remember that you cannot leave the inputs of your logic floating, so you should always terminate them. So the way you terminate them, you just put a pull up or pull down resistor, whatever it is, to turn it off. You don't want to leave it on. So what I've done here, I've tied all the inputs of my AND gate together, so basically it becomes just one input, and I've tied that to a negative 0 rail with a resistor, so it's always off, because we don't want to turn it on because it's going to consume power and it's going to heat up our chip. So it's always a good idea to turn it off. So if I had a NOT gate which it activates on 0, I would tie it to the positive, so it always stays off basically. So you should always remember, regardless of what it is, TTL or CMOS, you should never leave the input of your logic gates floating around, because all kind of funny stuff will happen if you do that, because they just float around, and then it's going to consume a lot of power, because it's going to go into oscillation, it's going to go into all kind of funny stuff happening, and you don't want that to happen, because the chip sometimes overheats, blows up, or all kind of stuff. You'll be in the proper gray zones if you do that. But yeah, I hope you this just shows you how simple it is to incorporate. This was a simple design. You can have a very complex design and still have your logic gates in your analog circuits. Lot of people do. I just wanted to show you that you can use them. You shouldn't always just stick to digital. They're not always just designed for digital circuits. You can use them in your analog circuits as well. I hope you enjoyed this little quick-ish video. If you did, please give a thumbs up. And if you like this sort of videos, please leave in the comments so I can do videos like this. Please subscribe, because that keeps the channel going. It keeps me going. And I would like to do things like this to show you my way of doing electronics, and how do I approach problems, and how do I solve them with just building circuits like this. Basically, it becomes like a Lego. If anyone's played with Lego, you got a bunch of Lego in front of you, and you just put them together, and by half an hour later, you got a house, you got a car, you got an airplane, or whatever your mind takes you. Logic gates and electronics, for me, is kind of similar. I just come up with, if there's a problem, or if I need to build something, I just go to the simplest thing. I write down what the circuit's supposed to do, then I just go to simplest components, and I start building up just like Lego. And by the time half an hour, 1 hour later, I got a full functional, you can see, little circuit working the way it should. There we go. I hope you enjoyed the video. If you did, please give a thumbs up, and if you like anything, leave it in the comment. If you want me to do any sort of different videos, leave it in the comment, and I will do. And until next day, have a good day.